One of the more common questions about limits on the AP exam is regarding piecewise functions. And the important thing to know about piecewise functions and limits is that generally speaking, they're going to ask you about sort of the interesting points. In other words, sort of the changeover points for a piecewise function. So let me just give you an example of that. Suppose that you had the piecewise function f of x is, and I'll make this really simple, let's say it's x when x is less than 3, and let's say it's, x squared minus 1 when x is greater than or equal to 3. Okay? If they're going to ask you a limit question about this, more than likely they're going to ask you the limit as x approaches 3, because that's where interesting things happen. To the left of 3, it's just x. To the right of 3, it's just x squared minus 1. I mean, to illustrate that, what if I were to ask you, what is the limit as x approaches 2 of f of x? Right, remember what a limit means. A limit means, what is this function doing near 2? Right? Well, think about it. When you are approaching 2, you don't even care about this function. This function only applies when x is greater than 3. So since 2 is like squarely in the less than 3 territory, all I really need to do is look at this top function. I can just evaluate this expression for 2, and I would find out that this limit is 2. Right? Similarly, if I asked you what's the limit as x approaches 5 of f of x, well, as x gets closer and closer to 5, I don't care what happens when I'm less than 3. I'm squarely in this territory. So I can just take 5 and evaluate it, evaluate this expression with it, and I'd end up with 25 minus 1, so I'd end up with 24. Right? The interesting question, the one that this video is going to talk about, is how do you do the limit as x approaches 3? Okay? And I need to point out, you don't just say, oh, well, this is the one you use when x equals 3. Remember, the limit doesn't care what happens at 3. The limit is interested in what happens near 3. And the thing that's complicated is that, well, this is happening near 3, and this is also happening near 3. So we're probably going to need to look at both of them. Okay? So we'll take a look at a few examples of this and sort of work through them. So here's this first example. Consider the piecewise function given by, there it is. It's one function when you're less than -2, and one function when you're greater than -2. And I'm asking us to evaluate 3 limits. One of them is the limit as x approaches -2 from the left. One is the limit as x approaches -2 from the right, and the other is the double-sided limit around -2. So, for this first limit, right, this limit as x approaches -2 from the left, if you're approaching -2 from the left, you're plugging in values that are less than -2. So for that limit, you're going to need to look at the function that gets applied when I'm to the left of -2. Right? Now remember, how do we handle all limit problems? We basically do all of them by attempting to evaluate the expression for the x value. So I will plug -2 into that. I'll end up with -6 minus 1, and I get -7. My left-hand limit is -7. Okay? Now what about the right-hand limit? I believe you guys should be able to pause the video, think about that, and come up with the answer on your own. So please do that now. So for this limit, where I'm approaching from the right, when I'm approaching -2 from the right, I'm plugging in values that are greater than -2. So this is the expression that I need to evaluate. So just like I've done before, I'm going to take my value here, my -2. I'll evaluate this expression using it. Let's see here. So when I plug in -2, I'll end up with 4 minus 4, which is 0. Great. So that's my right-hand limit. Now the next part honestly has nothing to do with piecewise functions. The next part is, so what's the double-sided limit? What happens when my left-hand limit is one thing and my right-hand limit is a different thing? What does that tell us about the double-sided limit? It should tell us that this limit does not exist. Okay? Now, if these had both been 0, great, then this double-sided limit is 0. If they had both been -7, great, the double-sided limit is -7. But if these are different values, then your double-sided limit does not exist. Now, one of the ways that they like to ask this question on the AP exam is they'll sort of not ask you what the limit is, but they'll just say, hey, here's a piecewise function that has, a little extra variable in it, has a little parameter in there like a. And they'll say, hey, if you know the limit exists, then what would the value of a have to be? And so I'd like you to sort of pause the video for a second, think about what it means that the limit exists. Think about what that means about this problem and what you might be able to do with it. So just give yourselves 30 seconds to think about that, and then we'll come back together and talk about it. So if the limit exists, it basically means that the left-hand limit, right, the limit as x approaches 1 from the left of g of x, that limit would have to be the same as the limit as x approaches 1 from the right. Correct? So, how would I compute this left-hand limit? Well, when I'm to the left of 1, I'm plugging in things less than 1. So when I evaluate this for x being 1, I'm going to get 1 plus a minus 5. In other words, a minus 4. That's the left-hand limit. Now I know some of you are like, whoa, 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 it's supposed to be a number. This is a number. This is an expression, and a is just some number that we don't know yet, right? This is the left-hand limit. So now I want you to pause the video, figure out what the right-hand limit's going to be. Right? For the right-hand limit, if I'm approaching from the right, I'm using values that are greater than 1, so I'll evaluate this expression using 1, and I'll get 2 minus a. Now the idea is, if I know this limit exists, then these two things have to be equal to one another. Longest equal sign ever. Right? So I'm in a position now where I have a minus 4 equals 2 minus a. If I move things around a little, I'll end up with 2a equals 6. And that brings me to the idea that a has to be 3. And that's it. You're done. And that's the end of the problem. One way that they will sometimes make these problems more complicated is they'll give you expressions up here that have both an a and a b in them. And all that means is you're going to have to come up with two different equations. You're going to end up with a system of equations that you need to solve. You'll need to use elimination or substitution or one of those methods to do that. I believe there are one or two problems like that in our exercises for tomorrow, so we'll get a chance to try those then.